it's so wonderful to see so many fresh, smiling faces this morning. I know we had a rough weather night last evening, and certainly there was some property damage, but for the most part, everyone in this area appears to have emerged safe and sound. And so it's exciting to move forward this morning. My name is Daniel Pullen, and I have the great honor of serving as the Dean of the Michael F. Price College of Business here at the University of Oklahoma. And on behalf of President and Mrs. Bourne, I'd like to welcome you to our annual Energy Symposium, where today we're going to talk about the important issues surrounding not only energy, but its connection to economic prosperity, as well as the connectivity to environmental concerns, right? How do we take these three big issues, these three big ideas, and make them mutually compatible? How do we prioritize them in a way that allows us to grow the economy, to keep it robust, to ensure the geopolitical importance of our nation, as well as the future of our world for generations to come? I couldn't think of a more exciting, important, sweeping topic than the one we're going to discuss together today. At the Price College of Business, we have recently adopted a new purpose statement, which is simple, it is bold, and it is clear. We call that the purpose of Price, and it's one sentence. The Michael F. Price College of Business ensures the enduring global competitiveness of Oklahoma and the nation. And what that means, even though that's one simple sentence, what that means is everything we do, every class we teach, every faculty we recruit, every student we yield to spend the next 4 or more years of their career at the University of Oklahoma, in some way it has to make our state and our nation stronger. And in a time of declining public funding for higher education, right, we have to be thoughtful. We have to, in many ways, behave as a private sector actor. Because if we're working with constrained resources, then we have to pursue constrained opportunities, which means we have to use data, we have to bucket, we have to prioritize. We have to identify the big issues that matter and then invest heavily and deeply and purposefully. Right? What are the things that are going to make our state and our country stronger in a sustainable way at global scale? And it should come as no surprise to any of you in the room that energy is one of those issues. And I'm proud to say that the Price College of Business, in every way, is all in on energy. Today we have 5 robust programs designed to prepare the future leaders our state and nation needs in this all-important industry. If you think about it, it's 14% of GDP. The energy industry undergirds virtually every component of our economy. Its geopolitical importance cannot be overstated. Historically, it's the most important industry to Oklahoma in this region. And if we're the second largest college and largest professional school at the University of Oklahoma, what are we doing if we're not having something to say about energy? And so I'm proud to say from the undergraduate level, our Robert M. Zinke Energy Management Program, which is the oldest, largest, most distinctive of its kind anywhere in the world, today is the largest major at the Price College of Business for undergraduates. Right? So getting our young people prepared and launched in their careers as they pursue the leadership roles that so many of you occupy today and have benefited from and have moved our state and nation forward through your careers. To the master's level, whether it's our professional MBA in Oklahoma City or our full-time MBA here in Norman, we have an energy concentration. So those students pursuing those degrees have a chance to take an affirmative step forward and pursue their Master's of Business Administration with an energy focus. To new executive education offerings like our Energy Executive Management Program, which is a 1-week boot camp for rising executives in traditionally technical fields who want to have an appreciation for the broad scope, the business side, if you will, of this industry. And let me take one moment to talk about the business side of this industry. While we have all witnessed the technological miracle that has come in recent years by the combination of such techniques as horizontal drilling and hydraulic fracturing. Right? It's been an economic miracle in many ways. What that means is that in many respects, and not to discount the importance of the technical side of this industry, but we have greater confidence than ever before that we know where the resources are. Right? Now it's about efficiency, and particularly in a softening pricing environment, it's about cost structure, it's about supply chain. Right? It's about management. It's about innovative financing. And that's about business. So I would say today, this industry is more about business than it's ever been before. And so I'm proud of our college to be addressing it so comprehensively. Last Friday night, we shared a very special moment as we celebrated the completion of our very first cohort in a new executive MBA in energy, which is a wonderful, innovative program. I think it's the most innovative executive MBA in energy anywhere in the world. It's a hybrid program where there's a portion of the experience that's shared here in Norman, a portion of the experience for our students is shared in an international location, but the majority of the executive MBA is done online in a very dynamic, interactive, social way, which allows the University of Oklahoma and the Price College of Business to use the power of technology to reach out and deliver a new type of executive education program to a new category of learners. No longer do you have to up and move to Norman, Oklahoma to acquire world-class business energy education delivered by the Price College of Business. All right? You could be a rising executive in any of the world's great energy companies. The kind of companies that are currently led by so many OU alumni today. And you can be in Norman, you could be in Dubai, you could be in Shanghai, you could be in London, and still have access to this world-leading education. Right? So it's technology at its very best, it's education at its very best, and it's about a college and a university willing to innovate to tackle the most important issues facing our state and nation as we fulfill the purpose of Price. Now I can tell you that the Price College of Business in many ways stands on the shoulders of our sister colleges and the century-long legacy of energy education that's been here at the university. Whether you think about the Mewburn College of Earth and Energy, which is home to the first and largest, perennially a top 5 petroleum engineering program, as well as other outstanding programs. If you think about what's going on in our College of Engineering, where we have one of the world's only natural gas engineering and management program. It's one of the only one of its kind that shows a full systems view of the natural gas industry. To the John Turner LLM program in our College of Law, really focusing on the legal aspects of this industry. And of course, all the work we're doing here in Price College. And today would not be possible without the combination of that legacy that so many of our colleges have shared with Price College over the years, nor without the collaboration and sponsorship fiscally and intellectually of our sister colleges. And so as we were putting this together, I can't tell you how much I appreciate my fellow deans and Larry Grillat and in Earth and Energy, Barry and Moore, and the College of Atmospheric and Geographic Sciences, where we find ourselves today. Tom Landers in the College of Engineering, Joe Harris in the College of Law, and many, many others. Some of those deans are here today, and please join me in giving them a round of applause for encouraging this process. And our 5th program, the Energy Institute, the namesake of this symposium, is a place where the best of .com, .gov, and .edu can come together, right, to discuss technological advancements, fiscal advancements, geopolitical advancements, policy advancement in an open, honest way that inures to the benefit of our state and our nation. And we have programs that are designed to advance the state of the art in energy research. In fact, I'm very proud of our Price College faculty who participate as part of the Energy Institute. In fact, we've received now 4 consecutive federally funded grants to explore business issues in this industry as sponsored by the Department of Energy's Energy Information Administration. All right, so it's no longer just the private sector, voting with their participation in what we're doing in energy, but now the federal government is also investing in the intellectual capital and the world-leading ideas that are brought about by connecting those dots right here at the University of Oklahoma. We've talked about the way we prepare our students through our teaching mission, and then, of course, outreach. Conversations just like the ones we're having today. Conversations that help shape the future of this industry and shape the future of the leaders who will drive it. And so I'm proud that today incorporates so many of our students, I look to you and I encourage you to lean in and be an active participant, not just a passive observer. Right? Work hard to create your own best future through opportunities like today. Do not let it pass. It is a very special time to be here at the University of Oklahoma. It is also my special opportunity to introduce an incredibly important person, one of the true visionaries in helping us conceive and drive and launch and execute the Energy Institute. He's going to be your master of ceremonies for today. His name is Bruce Stover. So many of you know Bruce, have worked with Bruce, have seen the power of an idea backed by the resiliency and sort of steadfast belief in it being executed, and executed at the highest level and executed right here in Oklahoma. Bruce is a retired executive vice president, a founding member of Endeavor International Corporation, which was focused on oil and gas exploration. He has virtually 4 decades of experience in this industry, a lot of background in international business development. He served as the senior vice president for worldwide business development for Anadarko Petroleum. He's been responsible for a tremendous number of deals. He's been responsible for moving a number of companies forward as they take a very global view of the importance of this industry. And I can tell you that experience translates every day in what has now been 3 years of important service as the chairman of the advisory board of the Energy Institute. I could go on and on about Bruce. Many of you know what an incredible leader he is. It is our great honor to work with him on virtually a daily basis, and I think that you'll enjoy his remarks as we move forward today. Please join me in welcoming Bruce Stover.
Thank you for the kind words, Daniel. We're excited to have you all here today. This is our 3rd symposium that we've done, and we're very pleased that you're here. Each year we kind of evolve in our theme. Daniel's mentioned what our theme is this year. I think just let me make a few comments from a personal point of view. From my position as watching this the vision for this Energy Institute evolve and what we're all about. First of all, I think as we look back at the last 10 years, it's been a phenomenal renaissance in the U.S. oil and gas business, particularly. The hydrocarbon sector has thrived because of the technologies that Daniel's mentioned that have been applied, and it's just been phenomenal. But at the same time, there's arisen a very contentious debate and a polarization of thought that's kind of invaded the space and the celebration of this great accomplishment, particularly in the areas of, what's the best stewardship of our environment, and particularly in the areas of climate change and our risk to potable water supplies, and those are legitimate concerns that we're going to address today. Too many times that's the elephant in the room. We talk about all the things that are going on technologically and business-wise, but it's the elephant in the room. So the elephant's got a suit on today, and the elephant's right in the middle of the room, and we're going to address it. So and we want to address it front and center. I believe, and so do the people involved with the Energy Institute, that responsible development, responsible continuing development of our hydrocarbon resources, energy resources in all forms, particularly hydrocarbon resources, together with real sustainable prospects in every area of environmental concern within our control, are not mutually exclusive objectives, that they can be all accomplished in parallel with each other with great progress. And we've seen that today. We're going to talk a little bit more about that today, the progress we've seen already and what we envision for progress in the future. Today's symposium is designed to explore the specifics of how that can happen. We want to present a constructive, responsible path forward that reflects a more balanced approach to the whole issue. Instead of polarizing the thought and polarizing the debate, we want to bring it together in a more central theme, in a right track, and so that we can begin to perhaps shape the tone of the way things are discussed. Because as I said, too often it's a polarizing discussion, polarizing debate. We want to get it back in a more constructive, right-thinking process. Will Rogers, who some of you may remember, Will Rogers was a more famous Oklahoman, a humorist. Will Rogers once said that good judgment comes from experience, and a lot of that comes from bad judgment. Well, folks, it's time for exercise of good judgment. Good judgment means, in the case of our topic today, relying more on common sense, good science, basic business principles like cost-benefit analysis, good science, understanding history, and global demographics, and what those things actually tell us about the things that affect us, affect climate change, that affect our water supplies and affect our water resources, and how those things how our thinking should shape our strategy and the resulting policy that evolves from adopting a strategy that's constructive, progressive, and beneficial to our citizens and to our nation. In my opinion, there's a lot of bad judgment being exercised by policymakers, the media, and the general population because of this polarized debate. I think that's a shared opinion of people involved with this institute. So we've kind of, as a university and as an institute, as a forum for outreach, we want to bring it back into the middle here and look at a balanced approach. So we've got folks. One of our panels is our academics from the university, and Daniel already explained. We're proud of our academians, leaders here at the university, and got a long legacy in energy-related education, and we want to have them a chance to present today. We've got people from the industry who will talk about their experience from the outside world, not only in the United States but globally, and how this all looks as we try to find this more balanced message. What does that balanced message look like? First of all, climate change is for real. It's a real deal. But it's happened since the creation of the Earth, and it will continue to happen. It's a very dynamic process. I think the real question is how much do naturally occurring dynamics of the Earth itself and the solar system in which we live impact it versus the human impact, and the human impact meaning its use of energy, and particularly more currently what people are concerned about is hydrocarbon energy. That's the first point. We acknowledge that. We accept that. And you're not going to hear anything different from that today. The climate change is real. Water, too, is a serious challenge. But water, and potable water supplies are important to us. And I think in the decades to come, I think it's going to become one of the most critical problems we've got. But in many ways, that relates to demographics. When I was an 11-year-old kid in 1960, there were 3 billion people on this planet. Today, there's 7. Okay? And that's a huge change in population. It's continued to go that way, almost exponential growth. We've got Hank is going to talk about that to a certain extent, but water is a big problem. Potable water supplies are a big problem, but we'll talk about that. The second point I want to make is that technology is going to be the foundation of our solutions, as it has been in the past, in realizing the progress we've made so far. I think technology has been used so far to help us evolve in our energy resource mix, to optimize the way we use energy, creating greater efficiencies in how we use energy, and our adaptation to environmental change that we cannot control in the future. Technology will be the answer. Finally, I think you'll hear this from us today. One of our themes is we must tell a better story. So that people's fears are better constrained by better understanding of the issues. It's a complex, very complex situation, complex issues, and we have to distill that complexity into things that people can understand and get their arms around. So that at the end of the day, we all work together to drive better strategies, better policy making for our country, for the good of our children, our grandchildren, and generations to come. We've made astounding progress already in many areas that affect our environment, while continuing to provide the foundation for economic progress and all of its benefits to the quality of life we enjoy in our country particularly. If we do this right, if we stay on the right track, I'm convinced that we can set a standard of performance that will be exported and be out there for everyone to follow in the rest of the world, particularly the developing world. So now it's my pleasure to introduce Mr. Randy Brogdon, who's a member of our advisory board, who will be the moderator for today's program. Randy is a group leader for the environmental and natural resources practice of Troutman Sanders, LLC, international law firm in Atlanta, Georgia. He has a broad-based regulatory and litigation experience in areas of air quality, permitting, and compliance, environmental issues of all types. He's a nationally recognized speaker and author on environmental law and has been named by numerous organizations as one of America's outstanding lawyers in the field of environmental law. So, Randy, we're pleased to have you today, and you'll enjoy the program.
Thank you, Bruce. It's always exciting to be back here at Oklahoma. I was talking to the dean earlier and talking about how exciting it is to go around the campus. When you're gone, you don't really appreciate all the growth, or you do appreciate the growth that is occurring here at the campus. And every time I drive around here, it's always great to see how much progress this university continues to make. I'm also excited about our panels today. Last night and over the past 2 weeks, we've had some vigorous discussion and debate about the issues we're going to discuss and reveal to you all today. We don't know exactly how that's going to come out. We've talked a little bit about some of these issues, and I think some of us will be surprised about what we hear today, and maybe you will as well. Let's talk about logistics. The format today is going to be, we're going to start with our academic panel. We're going to start with a 5-minute opening response to a question I will pose to them. After that, we have a series of questions that will be similar but not identical to the industry panel that will come after our break at 10:30? 10:15. 10:15. So we'll run about an hour and a half for this first panel and about the same for the other. As people are presenting their opening comments and responding to questions, feel free to take notes. If you've got something that has tweaked your interest, we're going to try to hold a little time at the end to answer any questions you all may have. That's the reason we're here. That's what Bruce outlined. We're trying to improve communications. We're trying to improve the interaction between the various fields so we can make good policy decisions. So with that, let me start with our academic panel. You all have the detailed bios in the brochures for today's symposium, but I'm just starting out chronologically and logistically here. Ron Boland, right here, serves as Assistant Professor of Entrepreneurship at the OU Price College of Business. He has over 20 years of experience in launching financing and advising new ventures. He holds a BBA in finance as well as a law degree from the University of Oklahoma, another fellow graduate. Next to him is Harold Brooks. Harold is a senior research scientist at the National Severe Storms Lab here in Norman. It was great last night at dinner as things got a little rocky. We were just kind of keeping as soon as he would look down at his BlackBerry, we're like, uh-oh, do we need to go? So it was a great person to have on deck last night during dinner. His undergraduate degree is from William Jewell College, and he has a PhD from the University of Illinois in atmospheric sciences. He's been the recipient of numerous awards for his work in the field and is a fellow of the American Meteorological Society. Next to him is Hank Jenkins Smith. He had earned his PhD in political science and public policy from the University of Rochester. He's currently a George Lynn Cross Research Professor in the Political Science Department at OU and the Center for Energy and Society. We study scientists, as he says. Susan Pistacco holds a Bachelor of Science degree in physics and astronomy and obtained her PhD in atmospheric sciences from the University of Michigan. After spending 8 years in the Planetary Geosciences Division of the University of Hawaii Institute of Geology and Planetary Sciences, she came to OU's School of Meteorology in '91, so welcome. And finally, Jim Sluss is the Senior Associate Dean and Morris R. Pittman Professor in the College of Engineering at the University of Oklahoma. He leads research, administration, and has over 25 years of combined academic and industry experience. He received his Bachelor in Physics from Marshall and his PhD in Electrical Engineering from the University of Virginia. So with that, it's a lot of introductions, and again, there's some detailed bios if you want some additional information. It's great from our discussions last night and over the past couple of weeks to see the different viewpoints The academic panel, instead of coming from one college, they're coming from several. We have great different and great diverse perspectives that will be provided today. So again, we're going to go with the opening 5-minute question. And so we'll start just down the row here. So the opening question is this. Taking into account your particular area of expertise, what aspect of climate change science does the public and the media most commonly misunderstand? And we'll start with Ron.
I guess I would approach that in a couple of directions. First of which, I would reiterate what Bruce Stover said. It's my contention, and what I have based a significant amount of my both professional and academic career on, is that the simple nomenclature that we use has polarized the debate both on science as well as policy, and most importantly, just sort of our area of expertise, which is capital formation. If you look at the 2013 EIA report, if with the simple change of acknowledging nuclear as a renewable energy, we would alter the stack of power generation in the United States such that we have surpassed surpassed natural gas just below coal as an overall generation statement. That is without one iota of touch to the science, to the underlying technology, but simply in the naming or the observation of the nature of the generation systems. Whether it be traditional or alternative energy, it's my belief that it is simply the naming of those two items that has polarized our discussion. And I would effectuate that with two items. The first of which is capital formation, which is sort of, as I mentioned, my area of focus. We use three primary mechanisms to encourage investment, both at the state and federal level in alternative energy. That's the investment tax credit, the production tax credit, and the renewable portfolio standard. All three of those are effectuated by the name by which we might apply to a power generation technology. For example, in the renewable portfolio standard, there's a bit of gamemanship. Each state will, and I believe at this point there are 39 states that have adopted a full RPS, each state will determine the percentage of power generation to come from alternative energy inside its geographic boundaries. And once that percentage is set, it is up to the marketplace to comply. So for example, in the state of Maine, which was one of the first adopters in RPS, they immediately said we will have 41% of the power generated in the state of Maine from alternative energy, which seems quite ambitious and quite high. But it, with the stroke of the pen, defined hydroelectricity, generated at that point at 42%, as alternative energy. So again, not looking to new technology, not looking to any new science, but with a mere stroke of a pen, we have polarized both the political system as well as the financing system by determining we're going to put this in this bucket. Each one of those tax mechanisms, the ITC and the PTC, most recently affected by, I think, what we refer to as the stimulus bill, the ARRA, we saw a significant movement in capital in the transition by the Fed cash out window on the ITC. Again, it is my contention that it is this sort of maneuver that has affected the flows of capital and thus the investment in energy, which I would like to believe is optimized for the generation source to the given locale. My final example, which I offer up to all my students, so I'll offer to you, is the duckbill platypus. The poor duckbill platypus has confounded science for eons. She will just not fit within one of the boxes that we have preordained. And that gives us great consternation. But the duckbill platypus really doesn't care. She's simply swimming, eating, and trying to be the best duckbill platypus she can be. Given that nomenclature, I would suggest that if we keep in mind the poor duckbill platypus, perhaps we can calm the debate on both sides of the spectrum by simply saying perhaps, just perhaps, the best thing for us to do is to optimize the power generation, or more broadly, the energy source, to the affected area and need. Thank you.
Thanks. Who's going here?
Hard.
Okay, yeah, me. Okay, me. Okay. I just want to. I'm really excited to be here because if I wasn't here, I'd be answering the question from the media, "Why more?" And
No, it's why more, once more.
yeah, why more once more? Yeah. So I conveniently was a little slow in responding to a message this morning. So CBS Evening News may not have anything tonight from me, but that's okay by me today. I think that if we try to think of what's most commonly misunderstood, I think that the very solid foundation that we know and we've known for 150 years that carbon dioxide will warm the atmosphere, and that our estimate of how much it will warm if we double carbon dioxide has been around for about 120 years now, and that really hasn't changed a whole lot, and that the planet's warming because of human activity. That's fairly straightforward. And for me as a scientist, I mean, I'm not a policy person, and so to me that becomes that simple scientific statement sets some ground rules for what we need to at least be thinking about in terms of policy. And one of the most important things is the fact that people don't actually care about the global average temperature. At least I don't check that on a daily basis. I'm much more worried about things like, my house didn't get hit last night, so it was a good day, and that what happens in terms of the weather. And what we've observed over the last, say, 50 years has been some dramatic changes in what we see in terms of variability of weather. In particular, tornadoes now are more variable than they used to be in their occurrence and their frequency, even though the average number has stayed the same over the last 50 years. We actually have 1/3 fewer days with damaging tornadoes than we used to have in the 1970s. But the number of days with a lot of tornadoes, say more than 30 of F1 and greater tornadoes, so the things that actually will cause some damage to you, has gone up by a factor of 5. Heavy rain. Oklahoma City, if you live around here, you know that if we get an inch of rain, street flooding and all kinds of garbage happens. When we look in the summertime in July, for the first 100 years of the record from 1891 up through about 1990, we averaged about, if in July, if it rained, there was about a 13% probability that we would have more than 1 inch. Now that's now up to 28%. We've doubled the amount of heavy rain. So the rain distributions, and this has been a consistent prediction from the climate models for a long time, that essentially without changing the total amount of rain falling, we would concentrate our rain more into heavier and heavier rain days and then more light rain days. And that leads to lots of issues involving with water. And one of those is that our current best estimate, and this is some stuff that's less than a year old in terms of from the research field, is that right now on our current pathway, by the end of the century, our probability of what we currently have as a once every 20 to 25 year drought in the Midwest, sort of Kansas, Nebraska, Iowa, summertime rainfall. So the one is 4% right now, probability essentially for each year. That will probably go up to about 25%. So that once every 4 years on average, on our current pathway, we won't get much of a summer wheat crop or a corn crop from the central part of the United States, which has some fairly strong implications for what we do. And that kind of thing needs to be added into when we look at cost-benefit analysis as we go in terms of evaluating policy options. And another water issue that is unrelated to how much water falls, sea level is projected to rise by about 2 feet by the end of the century, and will continue to rise after that. Almost certainly there will still be some, even if we do lots of things, that'll still continue to rise some. If you look at the city of Miami, about a 3-foot sea level rise, it's not that the city starts getting flooded, but all of their fresh water supply gets contaminated. And they no longer have fresh water in Miami at basically around 2100 without doing something radically different than what they currently do. And that's another one of those things that we have to really think about as we go forward in terms of trying to do policy options. So the work I do essentially hopefully provides information for people to make intelligent policy decisions. And I'm not a policy person, but hopefully what we do provides some information to those kinds of people.
I want to quickly move through some background information on carbon emissions and the way that they're understood. Am I advancing?
Yes.
Okay. So what I'm showing here is the evolution of carbon emissions by region of the country, and one of the things I want to draw your attention to is the stuff above the green bars. Those are the emissions from developing countries. China, of course, has got the largest fraction of growth that's taking place. In that next bar up, that's a grouping of developing countries that includes India. If you look at the top 5 emitters in the world now, broken out by the U.S., EU, China, India, you can see basically that in the EU and the United States, there's been a leveling off. And in fact, in this year, this graph doesn't extend that far, but for the 2014 data, we've actually seen a decline in U.S. emissions. This has led to a lot of discussion about the decoupling of economic growth from energy consumption and carbon emissions, which is really interesting to hear. I suspect that in the U.S. case, it was because we had a colder year and we didn't have to have as many heating days during the summer, and hence less coal consumption. And so I don't know that we expect to see the U.S. numbers continue to fall. What's interesting to think about this is from the U.S. perspective, from a policy standpoint, what do we do? What's sort of a shift of mixes of energy do we want to see? In our center, we study the way this is understood both amongst the public and policymakers. And what you're seeing here is the trend for what the U.S. public wants to see 20 years out. So in 2014, we're looking at the energy mix that's preferred in 2034. The evolution over time has been interesting. In about 2009, you see an increase in the fraction that, on average, people want to see coming from fossil fuels. It never rises to the level of that they want to see from renewables. Nuclear energy has dropped a little bit. Two events: the shutdown of the Yucca Mountain site, followed by the Fukushima event, account for some of that. But now you see in 2014 a relatively stable mix of preferences for how we want the energy mix to evolve. Now, if you look at the climate change attitudes, these are national data, and you'll see different numbers because people ask this question in different ways. Our question, we basically are tracking whether people think that human activities, burning fuel, are resulting in increased carbon emissions and hence global temperature changes. And there's about 3/4 of the United States who will say, yes, that's happening. Now, some of those folks don't believe that it's evident yet, that it'll happen in the future, but they believe that there's a connection. You can see that the fraction that do not believe that it's happening has declined a bit recently. And what's particularly interesting to me is what happens with these different groups. Well, the bottom portion there is basically just showing you that the people who think that climate change is happening are more certain about it than those people who don't think it's happening. And you know, makes some sense that if you don't think it's happening, it's in part because it's a less certain picture. But these are stable trends, and they're a part of the political reality. I don't know that you'd capture this from looking at the news media. The news media make it sound like it's much more a divided question, and in Oklahoma it may well be. But this is in the United States, this comes pretty close to a consensus that there is a connection between human activity and global warming. Now, if you break the population in 2014 down into those that think climate change who are pretty sure climate change is happening, those who are kind of in the middle and mixed, and those who don't think it's happening, you get different notions about the mix of energy that's appropriate. If you don't think it's happening, half of our energy supply in 20 years should come from fossil fuels, and relatively less proportionately from renewables. If you do think it's happening, which is, of course, a majority of the country, then you want to see a substantially greater contribution by renewables and less from fossil fuels. Those are essentially what's being traded off there as you move on that scale. Most people in the public don't understand really where we are on renewables and what the costs look like and what the implications are for the grid. So these are numbers basically that are coming from public understanding in the debate as it stands now. We expect that these kinds of values will change as other factors get introduced into the mix. We don't know what's going to happen to the proportion that prefer nuclear energy, particularly as the Fukushima issue gets closer to some kind of resolution. And understanding the grid and transfer of energy and storage of energy, those factors are going to play a huge role as we figure out what is feasible for the nation as a whole on renewables. But so that's basically the snapshot, and in trying to get at what the questions are that are understood and misunderstood, I'm trying to lay a bit of a basis for that. And that's basically what I've got to go on. And so I'll hand it over to our next speaker.
And one of the advantages of going later in the row is that I get to comment on some of the things that other people have already said. And I agree with Hank. One of the problems that we have oftentimes is that the media presents a very mixed view of climate change and make it sound like the climate community is very divided. In reality, about 96% of climate scientists agree not only that climate change is taking place, but that it is as a result of human activities. Another misunderstanding that there tends to be is that climate's always changed, and that's kind of my area here, that climate's always changed, and so therefore this is natural, and therefore we don't really need to worry about it too much. And it's true, since the planet's formed, climate's changed. It's been much warmer throughout most of climate history than it is currently. There have been times when it's been much colder. If we look a little more closer to our present day in the last million years or so, we know that the planet's gone through a series of ice ages where it's been both much colder than it is today. It actually hasn't been a whole lot warmer in the past million years than it is today. And when you see these graphs, you think, wow, you know, the climate really changes fast, but you have to look at the time scale on these. And when you look at that and you look at how quickly climate changes, we're talking about over thousands of years, 5,000 to 10,000 years to go from an ice age to an interglacial time, which is what we're in right now. If we put that in perspective of how the planet is changing now, basically in the last 150 years, we've increased atmospheric carbon dioxide by as much as it increases between a glacial and interglacial time. So in 150 years, we've increased by about more than 100 parts per million of carbon dioxide, whereas after a glacial time period, it takes on the order of 5,000 to 10,000 years for that much carbon dioxide to go into the atmosphere. As a result, between glacial and interglacial times, temperature increases by about 1/10 of a degree C per century. We've already changed almost a degree C, about 8/10 of a degree C in the last century. So it is an issue that we need to deal with. The biggest issue, even if we talk about climate's always changes, the fact of the matter is, as was noted by several previous speakers, basically the infrastructure and the human population has changed quickly. Even if we look at, a lot of people like to look back and say, well, you know, the medieval warm period, boy, this was a great time. They were growing grapes in England, and it was just wonderful everywhere. No one seemed to suffer. Well, the human population was much smaller at that time. In fact, it's not clear that the medieval warm period really was warm everywhere. Primarily, it seems to have been warm in parts of Europe. The United States, North America in general, during that time period, evidence is for mega droughts, not necessarily significantly warmer than it is today, but droughts, and that goes along with what Harold was talking about in terms of potential for drought as climate changes, and some places were somewhat cooler. So we had a much smaller human population, we had much less infrastructure, and so as we go forward and think about the environment and environmental changes, we have to take into consideration that we have much more infrastructure, that we have a lot more people. As Harold said, the population of Miami is likely to be without fresh groundwater because of contamination. And so it's an idea of we need to think about adaptation regardless of what the mix of energy usage is. We do need to think seriously about adaptation. We can't just say, well, it's always changed, so we'll just figure it out. We really need to plan. We really need to have some ideas. And just as a couple of examples of recent events that emphasize just how unprepared globally we are for a lot of extreme weather events. And again, you cannot take any one event and say it proves or disproves climate change. It's a long-term trend. You can't say one heat wave or one blizzard says anything one way or the other. But what we can do is look at our preparedness for that kind of disaster. And in fact, if we look, for example, at recent heat waves in Europe and globally, both in 2003, where tens of thousands of people died in Europe, and these are in developed countries. They're not in countries that don't have much infrastructure, but France and many developed countries had very large loss of life because of unpreparedness for heat waves. 2010, more recent issue where there were perhaps 100,000 deaths worldwide due to heat waves. So we need to think, how are we going to deal with those kinds of issues in the future? As Harold said, as extreme weather becomes more common, we have to figure out what we're going to do and how we're going to do it. And then just lastly, to add on a little bit, when Bruce was giving his opening remarks talking about water quality, we talk about climate change, and that is a very important issue. But we also need to remember what's going on in the shorter term as well, and that has to do with air pollution. And the World Health Organization has been doing a lot of studies in the last few years. They estimate that overall there are more than 7 million deaths, excess deaths each year due to air pollution, about half of those due to outdoor air pollution. And so 3.5 million people dying each year prematurely from air pollution, primarily having to do with air quality control in a lot of developing countries. But the problem is that the atmosphere isn't isolated. Just because air pollution is a problem in China doesn't mean that we're not going to feel that effect. And in fact, there have been a lot of instances on the US West Coast where air pollution is increasing because of transport from Asia. So it's a global issue. We can look at what we're going to do and hope that we set examples and help other countries, but we have to remember that climate is global, the atmosphere is global, water is global, and it's an issue that all of us have to keep in mind as we go forward.
Bruce, thanks for the opportunity to serve on the panel. I appreciate the invitation. And Randy, thank you for serving as the moderator. Let me just start by saying I can't think of a better place to be to tackle some of these issues, these research problems at the nexus of energy, economic prosperity, and the environment. And I say that because we have somewhat of a unique culture here at the University of Oklahoma in terms of promoting multidisciplinary collaboration. And I think that's quite evident from the diversity that you see in the academic panel this morning from a variety of different colleges. But I can point to a few examples. In energy in particular, there's a lot of collaboration between the Mewburn College of Earth and Energy, the Price College of Business, and the College of Engineering. I know in the area of weather, water, and climate, which certainly touches on what we're discussing today, there's a lot of collaboration between atmospheric and geographic sciences, engineering, and arts and sciences. And all of these efforts produce tangible results that improve public safety, improve economic prosperity, and improve quality of life issues, not only in Oklahoma, but across the United States. And so I think that OU is well positioned to be a leader in this area. My comments today, I've been asked to focus primarily on technology as it relates to improving energy efficiency and also the impact on mitigating environmental concerns. And the two are, I think, are intertwined. You really can't separate the two, because as you improve energy efficiency, of course, you reduce emissions. That's pretty clear. So if we look first at energy efficiency, what are the two things that drive energy demand the most around the world? And it's the generation of electricity, and it's also need for transportation, fueling our transportation. And so I'll have some remarks and some responses to my questions today in terms of the impact of renewables, primarily wind and solar, also on nuclear. I don't think you can talk about the impact of renewables without talking about the impact of smart grid technologies, because that's vital. In terms of transportation, certainly for light vehicles, the increasing percentage of plug-in hybrid electric vehicles and fully electric vehicles that are on the highways, as well as looking at other technologies that improve efficiencies and also biofuels. So if I first just say a few words about the impact of renewables, I think it's pretty clear, as Ron indicated, that they're certainly tied to geography. The wind blows, as we know here in Oklahoma, more strongly than in other parts of the U.S., and certainly other parts of the world are not as sunny as Southern California and the Mojave Desert, where you have opportunities to build big solar farms. And so there's the geographic issue, but there's also the matter of intermittency with these renewable sources that we try to build into the grid. Intermittency from the standpoint of the wind doesn't blow constantly and the sun doesn't always shine. And so that is where the introduction of smart grid technologies into our electricity grid is so important, because the smart grid allows us to more effectively integrate these variable sources of electric power generation into a system where, at least on a seasonal basis, the load, both the residential and commercial load for electricity, the demand, is fairly well understood. So it's a matter of matching up this variable supply with this fairly well-known constant load. So the smart grid technologies are really the introduction of sensing and communication technologies that allow us to communicate with wind farms, solar farms, and things of that nature, integrate that data, figure out how much energy is going to be produced and how to balance the rest of the generation portfolio to achieve an overall balance. And I guess, Bruce, you mentioned that one of the white elephants in the room was water, but I think the other white elephant in the room is storage of electrical energy. If you talk to a lot of operators over the years from the utilities, really the only viable option on a large scale for storage is so-called pump storage, where any excess electricity that you produce from wind or solar, how are you going to store that? You can't necessarily dump it all into the grid without causing a lot of instability. So one sort of brute force method would be to pump water uphill into a lake and then later use that water to produce hydropower to kind of balance out the supply as you need it. I think that for renewables to really be as effective and achieve their goals in the energy mix, we're going to have better storage technologies, and in particular we're talking about better battery technology, and I can say more about that later. So there are some new technologies on the horizon that I think have a lot of benefit that will rival solar, and that would be thermophotovoltaics, and I can say more about that in some of the questions later on, but that impacts not only electricity generation, but could also be a replacement for the internal combustion engine down the road. Battery technology is really, if we're going to see improvements, it's a balancing act between technology, durability, and safety. And so those are things that we're certainly going to have to address as we move forward. So I'll close by just saying a little bit about biofuels. I think we all know that biofuels are pretty prevalent. We can produce those all over the world now, but I think the question that it raises in the context of this discussion is, are biofuels, the production of biofuels, worth the cost in terms of the energy that has to be expended to produce them throughout the supply chain, and also the impact on the water supply?
Thanks, Jim. We're going to turn now to our list of questions here. The first one's going to be an open question to the panel, but I think I'll start with Susan. Hank talked a bit about public perceptions on the science of climate change, and it occurred to me that one of the most common statements I see in the press makes that not a surprising outcome. The phrase I see all the time is the science is settled. And when you repeatedly see the term the science is settled, you think the science is settled. And so since we have our academic panel here, I'd like to I'll start with you, but anybody else who wants to chime in on this, what is the state of science when it comes to climate change? Is the science settled? Is it a work in progress? Where does it stand? And specifically, I'd like to get some feedback on the accuracy of the models that are being used to drive policy decisions.
I think that again, about 96% of the climate scientists around the world, the science is settled. We're talking about a fundamental physical process that if you increase greenhouse gases in the atmosphere, the planet will warm. All we have to do is look at any of the other planets in our solar system. We can do some great comparative planetology, and you see that the more carbon dioxide you have in the atmosphere or other greenhouse gases, the warmer the planet's going to be. So that part of the science is absolutely settled. The part that isn't completely settled is it's a complex system. If we lived on Mars, it'd be a whole lot easier. I spent a whole lot of time studying Mars, and without oceans or people, Mars is a whole lot easier to understand. But we do have a complex climate system, so the response times, the feedbacks of the climate system are less well known in terms of their timing. So that's the one thing in our climate models that is still somewhat uncertain, is just how quickly change will take place. There's indications that there may be tipping points where climate may change or stay stable for a short time and then suddenly flip to another state. So it's the timing of the feedbacks and exactly when we'll see certain results that are still a little uncertain. But the fundamental idea that if you increase greenhouse gases in an atmosphere, the climate will change and will get warmer is, I think, pretty absolute.
And I'll go on just a little bit from that, and a little bit of a personal involvement story there. It depends on where exactly what details you're looking at. As I mentioned that, we don't really care what the global average temperature is in some sense. The global average temperature increasing, that's easy. That's sort of, first semester atmospheric science. And that's been around for a long time that's going to happen when you add CO2. In the face of the fact that most of the non-anthropogenic effects, such as solar changes in solar and volcanic aerosols, have actually been working towards cooling of the planet over the last 30 years. The fact that the planet has continued to warm is a fairly strong result for CO2. But when we start looking at weather, things become a little more complicated. I've probably written and been involved in more stuff on the impact of climate change on severe thunderstorms than anybody on the planet. And We have some fairly strong things we're starting to understand. The increase in variability is one. The increase in non-tornadic windstorms is a pretty strong result, not quite as strong, so some people may still dispute that. When we come to the question of tornadoes and what will happen to them in the long run, one of my best friends in the field, a professor at the University of Illinois now, who used to be a postdoc with us at the lab, we've written 5 or 6 papers together at various times. He was involved in a paper with another colleague at Stanford, who I've also worked with a lot. And they've got hints of tornadoes increasing in the future. And, Jeff and I met on, I've been on travel for the last week, and I don't remember all the towns I visited even. I think it was Monday. We met, and we still don't agree on the meaning of what the results are. So that's not settled. But, we're talking about details. Severe thunderstorms, bingo, that's easy. We have a pretty good, well, that's halfway easy. It's a fairly, we fairly understand. Global temperature is real easy. That one's nothing in terms of our understanding. But we get down to some of the tinier details. Yeah, we don't agree with each other. There's still room for doubt. As far as the models are concerned, current climate models are an absolutely spectacular use of physical principles. In fact, we look at older generation models. In the mid-1980s, some former colleagues of mine, my master's degree was from Columbia, and I worked at the Goddard Institute for Space Studies. They ran a long-term model projection that suggested that after 10 years of increasing temperature, that the planet was going to continue to warm. In the face of natural processes such as solar, almost certainly wanting the planet to cool. And by golly, it's happened. The model was slightly more sensitive than what our current to carbon dioxide than our current models are. But the thought that you could actually forecast that 30 years from now we would actually not have had a year cooler than any of the years previous to that model run was an amazingly strong prediction, and it was right. And that's several generations old modeling technology now. No one would even, you can run that model now probably on your smartphone. And so our models have gotten more sophisticated. Right now we can model, or even 8 years ago, we could model, at least on the continental scale, the long-term evolution of temperature around the world for all the different continents, show the difference between what happens with and without carbon dioxide and other anthropogenic influences. And there's no way you can explain the temperature growth on a continental scale, not just a global scale. No way you can explain it without having the anthropogenic effects in it. And those are really spectacular and strong results from the model. Now, day-to-day weather? No, they can't do that yet. We're starting to get some hints about the kinds of things involving with things like severe thunderstorms and heavy rains and all that. But we're not quite there on those.
When you ask the question about settled science, you're wandering into some difficult. I mean, this is terminology that we use to try to get at something very complex. But you got to remember that science works in large part because we have a large number of people who are working partly in competition, partly in collaboration to study a set of phenomena. And so they develop hypotheses, and these are drawn from theory, and they create empirical data in order to test those hypotheses. And if you looked at the scientific community as a whole, we do know that a very large majority of those who work on climate science believe that there is a strong connection between between carbon emissions and other greenhouse gas emissions and global temperature. But there are, as Harold and has been just describing, when you get down to the local scale, you get an awful lot more variation in the way these things are understood. It's possible then for somebody looking at the science to believe that it's not settled, that there are in fact differences between what scientists believe, because it's multidimensional. There are different kinds of questions that are being asked, different levels of consensus on these issues. Now, that's normal in science. In virtually every field, there are differences, and in some cases there's a whole lot less consensus than we have on the climate case. What makes this one a little bit different is that the findings from climate science are connected to real live human interests here on the planet. Those real live human interests are infused in our political process and our economic systems. And what that means is that stating that there is an outcome, that carbon emissions are associated with rising global temperatures, actually affects interest in ways that draws the political process into the scientific debate. Science is an extremely resilient and robust process. It's the best method we have for accumulating an understanding of the world, but it's not resilient to intense political debate. It doesn't work that way. It's not a binary system where there is truth and falsehood, except in rare occasions. It moves forwards in small steps. It gradually accumulates understanding and consensus, and its implications are understood with some blind alleys and false starts and other more robust directions. And so when you infuse intense political debate into a process for the accumulation of knowledge that's not resilient to it, you get really messy kinds of results of the sort that we've seen. And you know, it's intriguing to think about the beginning of this debate. It's gone back quite a while. But many of the early statements about climate change were not just statements of science, but they were also statements about who's to blame. So the science was immediately attached to blame mongering. And that, boy, I tell you, if you want to poison a scientific debate, there is absolutely no better way to do it than that. Instead of making it a cooperative process where we understand that we have a common problem, and we've got a variety of different mechanisms that we can pursue to address that problem, we made it one that pits the direct and immediate interests of some groups of people against others. The language of demonization has escalated to the point that it is crazy. And I'd say, is it a settled science? It's certainly, compared to many fields of study, this is more settled than other things that we have no debate about. I want to make one quick example that we see this happening in a parallel field that I think is really instructive for this is vaccines. Until recently, it was a settled science. We had no significant societal debate about whether vaccines were a good idea. But that now has become attached to politics with a lot of blame pointing and a lot of consideration of high stakes. When that happens, you can imagine that the scientific debate is going to start looking a whole lot different than the political debate.
And the one last thing that maybe I would add is that I always tell my classes that, you know, the science of climate change is pretty darn well understood. What we really need to be doing is having not scientific debate over this, but social, political, economic debates. That's really what we need to look at. We need to work on this as an issue that is for all of us to try and solve.
I'll direct this one at Harold. I'm glad you're here today because I think one of the most misunderstood issues is the difference between weather and climate. We see this messed up in the press all the time, and in just casual discussions you have, people confuse those a lot. So what's the short answer if you have to set people straight on the difference between weather and climate?
Okay. I'll use an analogy I don't like because it's actually kind of works. I just didn't like the way the guy came up with it. That climate's is your personality and weather's your mood. You know, there are times when, you know, some of you out there may actually be really nice people. But on the way in, you know, the jerk who cut you off on the road, and then you got the speeding ticket, might turn you into not a very nice person this morning. So that's one thing. And then, perhaps a more formal way to look at it is that weather is climate is sort of the background state, and weather, if you can imagine this from a statistical standpoint, is the draw we take out of that bag of probabilities. And that some of those things, you know, rare events are going to happen no matter what. I mentioned some of the stuff we've done with long-term climate projections and looking at severe weather things. For the Southern Great Plains, there's this one figure I really love from one of my colleagues where you project the annual number of severe weather environments favorable for severe weather as things warm, and there's a long-term increase that's like by 25% from 1950 to 2100 in this climate run. The next to last year of that 150-year run has the smallest number in the entire 150-year record. It looks like it's less than a quarter of what's the average at that time. And you're going, man, you know, that year what the heck happened then? And one of the really early years is way up. So even though there's a really, really strong trend upward, you still get some small years at the high end and some big years at the beginning. And that's one of the issues between weather and climate is the fact that, things happen anyway. And that some rare events are going to occur no matter what the setting is. If we look back to recent heat in this area, comparing 1980 to 2011, so 2 really stinking hot years in the central part of the United States. If you look at the background temperatures, 1980 sticks way up above the long-term trend. It's very unusual. 2011 was slightly warmer than 1980, but it's not as far above the current, sort of the average, if you take the average 20 years around it. And so that's the kind of thing that we have to worry about. And one thing is how those, as we change the background state, now having a 95th percentile event happening means it's going to be a more extreme event than we used to think it was being a 99% event.
Let's shift to the issue of demographics, because that was something that was highlighted early on by Bruce, and I'll direct this one at Hank. What is global population growth and demographics? What do they tell us about the impact of human activity on the environment, and how do we address that growth going forward in fashioning climate and energy policy?
Well, this is a tough one. Globally, there's a negative correlation between the per capita GDP and growth rate. So poorer countries tend to grow at a much more rapid rate. This introduces one of the most interesting problems in estimating carbon emissions, and it's a really interesting conundrum to energy use, and that is that in many of these developing countries, one of the major forms of fuel use is wood and other organics, such as animal dung, as a fuel for cooking, heating, and home health. And some of the statistics that the World Health Organization has come up with about the fatalities that are associated with pollution, both indoor and outdoor, are associated with that. In developing countries, the palls over cities that are a function of the fuel use there, and within household, boy, I tell you, the inside household pollution concentrations and the disease that's associated with that are phenomenal. So if you noticed on one of the charts I showed, there was a great deal of uncertainty in carbon emissions associated with some countries less than others. And we're pretty good at calculating these carbon emissions associated with cement production and with fossil fuel production, but much less so with respect to these other kinds of uses. And one of the great ironies that's associated with this is that in many cases, the carbon emissions associated with these, wood fuels and dung fuels are worse. Partly because they're associated with non-carbon greenhouse gas emissions, and partly because of the other disease-generating aspects. They're worse than fossil fuels. I mean, so you could imagine a pathway forward where some of these countries are increasing their fossil fuel use, switching away from these traditional wood-based and other fuels, and so even though their fossil fuel use is going up, their carbon emissions are going down. As we shift from one type of fuel to another. Figuring out how to generate that is pretty tough. India has an enormously aggressive nuclear energy program, in part because they realize that they've got to produce enough electricity to make it sufficiently stable that the demand for it can rise, so that they can shift off of these more makeshift fuel uses. Note that wood fuel also means the consumption of trees. In many cases, it's jungles and forests, and when you have deforestation, that's another contribution to carbon emissions. And so this is really challenging. In the places where the biggest demographic growth is taking place, we have some of the greatest uncertainties and some of the biggest challenges as we shift across fuel uses. There may be really important uses for fossil fuels as that transition takes place in order to get to a lower carbon emission in those areas. And so it's not simply an argument for let's get rid of fossil fuels. You can't do that and make our way to a world that in many of these developing countries where we are actually able to reduce carbon emissions.
Any other comments on population growth?
I guess I'd like to add a little something, having been involved in this personally and professionally. You're absolutely correct. And if you, I think Dean Pullen identified 14% of GDP as energy. In lesser developed nations, it's a very linear calculation of between 7 and 8% is directly related to power. And more importantly, GDP cannot grow without power. So you essentially get involved in a very hairy debate geopolitically to say, are we going to restrict essentially the transformation of a lesser developed nation by effectuating developed nation policy? And I think, I'm not sure exactly how we get that settled. We do know that numerically you cannot grow a nation without power. The question becomes, how do we get that done in the most efficient way? And typically, when I have been involved in this, the comments we get out of policymakers in the lesser developed nations is, how dare you keep us from our own industrial revolution? And I think that's a very important note to make, that we, in fact, through our policies, may be trying to force upon a different geographic location those mandates that we might apply to a developed nation. But I think you're absolutely correct, and I think that the linear correlation between growth and power supply is absolute.
Let me just add one more thing about this, and that is back to the political complications. The greatest showstopper in the United States for getting people to agree that our energy policy should take seriously limits on carbon emissions is when somebody hears that, well, the greatest growth in carbon emissions is in China and other developing countries. And so in the U.S., the political will to act on our own account is in part a function of the perception that there is rapid carbon growth that would simply swamp any reductions that we would make. So why should we invest huge cost in reduction of carbon emissions here? Simultaneously, in those developing countries, there's the perception that the developed countries already spewed their carbon. They had their chance to leverage up. And so now why are they, the developed countries, turning around and telling them that they don't get their chance? So you get a catch-22 here that is a really serious global political conundrum that we're going to have to unravel.
Let's turn to the issue of technology. As dynamic as I think the climate science is right now, technology is at least as dynamic, if not more. And one of the discussions we were having last night, it took 66 years from the launch of the Kitty Hawk to landing on the moon. That's a 66-year period that fundamentally changed how that technology, aviation technology, evolved. And when we talk about climate science and how we develop policy around there, we're talking about what's going to happen in 50 years, in 100 years, and we talked about 2100 in Miami. So what is technology going to look like, and how is it going to fit into energy policy and climate? And I'll direct that one to Jim.
Well, that's a really broad question, so I'll just take a couple of bites out of it.
Take your swing.
And I guess I'll start with, let's look at energy demand for transportation and a couple of examples there. I have seen estimates that the number of light vehicles worldwide will double within the next 20 to 25 years, yet the fuel consumption will stay about the same as it is right now. So why is that? And of course, it's improved efficiencies. In the United States, we have CAFE standards that have continued to improve the energy efficiency requirement of our vehicle fleets. And I think you're going to continue to see that efficiency improve through the increased use of plug-in hybrid electric vehicles and fully electric vehicles into our light vehicle fleet. Now, having said that, it's kind of interesting when you consider the environmental impact. That was on the fuel efficiency side, but yet the carbon footprint of introducing those technologies varies depending upon what part of the country you're looking at. In California, for example, there's a high concentration of electricity generation using natural gas and using renewables. And so to charge up your plug-in hybrid electric vehicle or fully electric vehicle represents a different carbon footprint than if you live, let's say, in West Virginia or Georgia, where you're generating most of your electricity by burning coal. And so, yeah, you're achieving better efficiencies, but you're you have to be careful about what you're saying with regard to the carbon footprint. So having said that, on light vehicles, I've also seen some projections for the growth of transportation fuels for heavier vehicles, so trucks, cargo ships, airplanes, and there are good opportunities for improving efficiency and reducing carbon footprint as well, although the demand is going to continue to rise. And I was on a Finnair flight last week from New York to Helsinki, looking through the in-flight magazine, and I was struck by one of the statistics that was in there, and they said that we are going to reduce our carbon emissions by 24% per seat by 2017, and that was over 2009 levels. And so, okay, I got kind of curious, how are you going to do that? And started to dig a little bit. And it's technology that's going to allow them to do that. More efficient jet engines, turbofan type engines, the winglets that we have seen over the last decade pop up on pretty much all commercial aircraft in the United States that reduce aerodynamic drag and improve fuel efficiency. But then also some pretty straightforward things, just like changing the way you fly, your flight path and the speed at which you take off and approach for landing, things like that. So it's a broad mix of how you're going to achieve that.
And I think an important part of that mix is technology and especially the evolution of renewables. And I'll open this up to the panel, obviously for you, Jim, but anybody else that wants to take this. One of the questions I get, I work on a lot of renewable projects, and people get very excited about that and say, well, why don't we simply shift from fossil fuels to renewables? Why can't we just get around to getting that done? And it takes a lot of explanation to explain some of the limitations in renewables, but I'd open up to the panel, and you can start it off, Jim. What are the limitations what are the realistic restrictions and limitations on a transition to a more robust renewable portfolio in our energy mix?
Well, I think we can make some progress. We have made progress toward that, and we'll continue to. I think of the renewables that we tend to think about, wind is probably the most mature from a technological standpoint. I think the answer is going to be that mix is going to obviously vary based on geographical considerations. I've seen some Department of Energy projections that the level of the mix for wind, just wind, may be as high as 25% in some regions. And in fact, in talking to some of the members of our Power Board of advisors here at the University for Electrical Engineering, they say that in some parts of our mid-continent region, we see at peak times as much as 40% of the electricity being on in any given day being generated by wind. So it can be quite high. Prospects for solar, I think, are still limited by the cost of solar. There are prospects for more efficient solar cell technology, but as you get more efficiency, you pay a higher price for it.
And I'll jump in on that. I tend to take a much lazier approach, probably because I feel like the Howard Wolowitz of this panel being the only one without a PhD. But given that background, I would tell you that we tend to, certainly with our own capital deployment in some of the activities I'm even currently involved in, is we look for those patterns of least resistance, those which really look towards optimization. If you're a finance major, we're looking for the efficient portfolio, right? We're trying to get out to the absolute edge. An example I might use would be wave and tidal energy, which has always been intriguing. We've seen a couple of massive failures in the public markets in that particular sub-vertical. But I would add these numbers to sort of that understanding. Typically, it's about 37 cents per kilowatt hour to generate wave-generated electricity. We compare that to, say, coal, which can, on a good day, you can play that between 1 and 2 cents. Nat gas will come in between 4 and 6. And we have other numbers we kind of work with, but you think in terms of 37 cents per kilowatt hour, there would be absolutely no way we could ever implement that. And I think part of this goes to the base nature of the discussion today. Well, that sort of data on a broad stroke or a broad brush would make it almost impossible to anticipate the adoption of something like wave and tidal. However, if you are a fishing village in the Aleutian Islands in Alaska, where you fly in 55-gallon barrels of diesel to burn in an aged Wärtsilä facility, you're at about 55 cents all in when calculating transportation costs per kilowatt hour. So now all of a sudden 37 cents starts to look pretty good. So what we do, both from a capital deployment standpoint as well as sort of from an overall efficiency of the marketplace, is we look for those places where there is an optimization of the technology, both from a cost and capital formation standpoint, to the given locale. I agree 100%. It's going to be extraordinarily difficult, and we get asked this question on a regular basis. Will there be a national renewable portfolio standard? In the year 2000, when the Gore campaign was ramping up for its presidential run, that was asked of us, is there going to be a national portfolio standard? And I said, well, that's going to be extraordinarily awkward when you tell the residents of Georgia that 8% of your power must come from wind. Or if you go to Arizona and say you must deploy hydroelectric.
A lot of trees to cut down.
Yeah, there's a lot of work to be done there. I don't think we're going to see it on a national level, but again, if you look at a given locale or the optimization of both the technology and the locale, we can do certain things, and this is where we sort of cut our teeth. If we bring, and I'm obviously for our discussions, I'm focused on power. This can actually be done in hydrocarbons as well, but with regard to power, if you can reduce the size of the supply input increase, the delta increase, so that you're more closely aligned with the slope of the demand curve, you actually effectuate two things, one of which you increase ROI because you do not have what we would refer to as fallow capital or fallow assets sitting still, but more importantly, then you don't run into long-term debates based upon an extraordinarily high capital investment. So for example, if I was to build a hydroelectric plant, which I doubt one will be built in the United States during my lifetime, but if I was to build a hydroelectric plant, from concept to actually COD, delivery of that project, we're looking at a minimum of about 15 years, regardless of run of river. I'm talking about a true standard hydroelectric facility. So if I'm going to take 15 years, and it's going to cost me in the neighborhood of $75 to $100 million to build a small facility, I need that facility to exist for a very long time. Therefore, I'm going to build my supply way above the slope of the demand curve. That means I've got impact to both capital sources as well as the environment at a time period that's not needed, and I'm betting, both from a financial standpoint and overall economic standpoint, that the demand curve will meet me at some point. So we look to the usage of technology, as Jim mentioned, to better align those two factors, the supply and demand, so that we both do two things, one of which from a financial standpoint, it makes more sense. We tend to look to those things because they're simpler for us to calculate. And more importantly, we do it from an environmental standpoint because the fact of the matter is if I am building much larger facilities, I may be pushing my supply well above demand, which actually does very little to progress the overall discussion.
If I could just add briefly to that. There's two dimensions of the evolving technologies that are interesting to watch. One is that just as is the case in the science, you can select your facts across the possibilities of renewables to make a case for one side for the other. And when I measure perceptions of the world, there are people who are really wedded to a carbon-free world will tell you all sorts of glowing stories about what's possible with technology that absolutely conflicts with the perception in the minds of those who don't see that as necessary. And so technology discussions themselves are kind of shot through with difficulty because of precisely these points, that different technologies may be applicable in different regions. On the dam side, of course, Arizona does produce a heck of a lot of hydropower.
Yeah, they actually do. That was a bad example, actually. Well, actually, one of the best pumped hydro facilities are in Arizona that Jim was mentioning.
That's right. And what's interesting there is that we're cutting back on the utilization of our hydropower in the United States because river rafters want more controlled flows that don't generate electricity at the rate that it's demanded. And so our facilities like the Glen Canyon Dam are increasingly constrained to operate in interesting ways that don't match electricity demand. We have taken out some dams in the United States, and hydropower is one of those areas where technological change and policy change is going to be most interesting to watch. We have lots of small dams in the United States. If we had more efficient small-scale hydroelectric generators, you could fit a lot of those with power generation. And of course, we can rewire and utilize the existing hydro facilities that we have in the United States. This is an area that's been polluted by a controversial debate. For the building of the big dams in the United States generated so much opposition over time from environmental groups that in many instances there's a sort of a hardcore take them all out attitude, which doesn't fit really. I mean, the dams are there. If you take them out, you're not going to return to what might be viewed as a natural state, though there is no natural state. We're always changing. We probably should optimize from where we are, both technologically and with the energy sources we've got available.
I want to add just one thing, and I agree 100%, and specifically with regard to hydro. I was actually involved in a project of what would be referred to as river reclamation. So there was actually I think this is probably referring to the Silenced Rivers book.
Yes.
I think it was written in 95, 97, that time frame. A book was written called Silenced Rivers, which sort of generated a significant amount of public approach on this. So a decision was made to reclaim a river by the destruction of a dam that had been built during the WPA in the Pacific Northwest. And the controversy was exactly surrounding that, and it got to a fevered pitch of arguments, not to the owner of the dam, and frankly, not to those individuals that I sort of laughed about, had paid a premium to be lakeside, who are now going to be a mile bogside to the river, who were rightfully so, in my opinion, were claiming, the right to restitution for the loss of the property value. But really the fevered pitch, and when the town hall meetings and those sort of things were going on, the fevered pitch actually came about between two environmental lobbying groups, one of which was demanding the immediate destruction of the dam, the other of which was suing to keep the dam, claiming that the destruction of the dam would cause. And so, again, from my sort of narrow scope of the world with regard to the business economics and the finance of that issue, there was a significant amount of time where we just had to sit and wait for the noise to calm down. And I'll reference back to my opening comments, which is when the noise gets so loud in a polarized debate, many times it becomes a challenge to move forward into the center. And as sort of a conclusion to that story, I was sitting in a meeting with the chairman of the board of the owner of that particular dam, and we were getting the reports from the environmental groups, and the lawyers were telling us who were suing us and that sort of thing. And I was quite younger then, I swear, but at that point, my boss looked at me because I had quite a strange look on my face, and he asked me what was my opinion of this situation where we had to make a decision about whether or not we were going to demolish this dam. And I said, well, I've waited my entire life to use this phrase appropriately. Truly, we are damned if we do and damned if we don't.
Yes.
On that note, let's close out with the issue of communications, and I want to turn to Susan because she had some really insightful comments about communications and politics and polarization and the effect that has on science and our ability to move past debate and to actually get things done. So this will be an open question to the panel, but I want to start with Susan.
I guess, I think about, when I think about science issues and how they need to be approached, I think about, for example, back in the 1980s, 70s, 80s, early 90s, the issue with ozone depletion. And countries eventually recognized that ozone depletion, stratospheric ozone depletion, was a global problem, that it was something that everyone needed to get together on. And it wasn't an easy process. There were several global meetings where people had to get together and come to agreements. The developed countries that had alternatives to chlorofluorocarbons were able to give alternatives to developing countries for the replacement of those gases. And as a result, we've got a pretty strong protocol in place that pretty much every country, some a little more reluctantly than others, have signed on to. And as a result, we see the level of chlorofluorocarbons decreasing in the atmosphere for the most part. Some recovery of stratospheric ozone. It's slow, it'll take a while. But it takes global discussions. And I remember at that time, one of the things that got people really upset in the US was that you could no longer go into your local automotive store and buy Freon and you would have thought the world was coming to an end. It's my God-given right to go into AutoZone and buy Freon for my car's air conditioner. Well, you can't do that anymore. The rechargers you buy now are not chlorofluorocarbons. You actually have to get your car's air conditioner fixed so that it doesn't leak. And that's the kind of discussion, but those are sort of the knee-jerk reactions that we have. It's the same sort of knee-jerk reaction people have. What do you mean we're not going to be able to buy incandescent bulbs anymore? That's not right. People everywhere are a little resistant to change, but we have to start discussing it. We can't just be polarized and say, this side's right, this side's wrong. We really need to come together at local levels, national levels, and global levels to really start discussing the different issues and the best way to go forward, I think.
I want to leave a little time for questions. Do we have questions in the audience? Any hands? Do we have any? Yeah, we have a few. So let's. Still have some time, but let's have some closing thoughts on communications, and we'll turn to questions and get those answered.
Real quick, Susan brought up the ozone thing. There was a lot of resistance from a lot of people when there was no technological solution for CFCs, and they actually started arguing about the science side, even though the science was very clear as to what was happening with CFCs and ozone. As soon as the chemical companies developed alternatives to CFCs, all of a sudden the discussion about the science stopped. And one of the comparisons to now is that there were no winners in the ozone debate. Skin cancer, most people think is bad, and that was one of the big impacts. With carbon dioxide, one of the issues is the fact that there will be winners and losers if we change the mix of carbon. And that's, I think, one of the things we're dealing with. Otherwise, this is such a parallel situation to what we dealt with in the 80s.
The key point there is decoupling the science debate from the solution debate. And that's challenging. It may mean that we really need to be talking about combinations of things, not just reductions of emissions of greenhouse gases, but some kinds of geoengineering that would permit us to recapture those that are emitted, either at the stack or that are more fugitive types of emissions. And one of the things that we have identified in social science research on this is that you can diffuse some of the polarization by broadening the array of solutions that are being given credibility, so that people of different worldviews can begin to see that they have a place, that there is something for them, that it's not a complete zero-sum type of competition where winners exist only at the expense of losers.
Thanks, Hank. Let's move to questions. Our time looks still pretty good, so we'll take a couple of questions and have our break, and then get back with our industry panel. So let's start. I think I saw a question up here.
Yeah, maybe whether they're related questions or separate questions, but blame mongering, thank you. We're dealing with politicians and their constituents who haven't had a science class since the 7th grade and have never taken a statistics class, regardless of which side of the fence, if there's only one fence there. When we look at atmospheric conditions in the past, are we using ice cores? Is that the reliable source? Is there a lot more involved there? When we another part there, the reducing things to sound bites as we try to persuade people one way or the other. You talk about saltwater, freshwater interface, and we've got glacial melt. The Himalayas provide so much water, for example. Is that a place where we can create a simple argument of here's the effect, and it's regardless of the cause, we're on a course where it's going to happen. Finally, maybe this isn't the right time to talk about it, but LNG and Powder River coal being exported, how that might play into India, China, Russia, Germany with no nuclear. So sorry to be so broad, but throw it all out.
Well, I'll take a first stab at some of the paleoclimate indicators. For the past million years or so, we do look at ice cores in part, but there are so many different indicators that we use. We use tree rings, we use geological formations, we use seashells, we use corals. Really, the number of paleoclimate indicators is quite large, and it's like anything, you never want to rely on one source. And so we do have a lot of different indicators that can tell us something about global and as well as regional climate in the past. And one of the really nice things about ice cores, of course, is that you actually get parts of the atmosphere trapped in the bubbles. So you can actually test what the atmosphere was at those times. But we have reliance on a lot of different indicators. In the same way, when people argue about, well, is it really warming someplace? Aren't we just building up cities and that's what's making things warmer? There's such an enormous network of satellites and weather stations and so on that are making measurements that, again, you never rely on just one resource. You look at the whole and try to build a coherent picture.
And there's correlation generally?
Absolutely, absolutely. And one of the things that we find is that, for example, in the past, places don't change in the same way. Some places sometimes get a little warmer. Other places might not change, maybe even get a little cooler. You might get drier in one place and warmer. We know that there is regional variability that's due to a lot of different reasons, but we can look globally and also get a coherent picture.
Yeah, and on that last point about the regional, there's a really exciting paper that just came out last week looking at the slowdown of the North Atlantic circulation. The only place on the planet, essentially, that has cooled over the last century, when you look at the long term, is the North Atlantic near Greenland. And as a result, the Gulf Stream has slowed. And the reason it's cooled is because of the melting of Greenland, putting fresh water out into it. And now, the long-term impacts of that are intriguing. But that's one of the kind of things we can actually tell now that probably 50 years ago we wouldn't have been able to put the data together to actually answer that kind of question.
I have time for one more.
My name is Dr. Eddie Williams. I'm with Black Crystal Energy. I'm fascinated with the discussion of the, what I would call the intellectual section of the panel, where we deal with cause and effect, but there is a triadic problem that I have because we're dealing with cause, effect, no solution. And we've been looking at these things from different spectrums. We look at the issue of environmental pollution, the problem with emission trading and chlorofluorocarbon and all this. But what do we see as a pattern of solution for the future? Because the idea is we know what the problems are. We know what is causing the problem, or what are the causes of this problem. But what are the solutions for the generations unborn? Because they are going to be dealing with this issue when we are done. What do we leave behind for those who are coming from behind? What are the scientific trends? What can we look forward to in the next 20 years? What are the vision of this university or this intellectual gathering for the year 2020? What are we going to do about the problem?
There you go.
In 60 words or less.
Yeah, so first off, there are going to be solutions coming up at different levels. We've talked about some of those now. Technological change and economic incentives in the business community and in the economy are going to lead to changes. The problem is that those won't be happening at the rate that many argue is necessary to have a material effect on changes in the atmosphere. I think where we live in multiple layers of systems. There is a collective decision-making system that realistically we have to work within. And so now we have to get smarter about how we engage in the cultural, economic, and political debates associated with carbon emissions. There's a great deal of work going on about this, but we have got to stop the demonization. We've got to start creating a way of talking about solutions that creates room for energy companies, where geoengineering plays perhaps a much larger role. We've got, some of the biggest proponents of addressing climate change problems are also our biggest hurdles. Those that, for example, will not countenance nuclear energy as a part of the solution problem are themselves a major part of the problem. In fact, I would attribute as much damage on the carbon emissions debate to those who simply refuse to consider all of our options as those who are the climate change deniers. So right now, we've got to start getting sensible. We've got to start making the implications of these stances clear, but we've got to do so in a way that assures that we're not simply locking people out of the debate. That's our challenge. There's a great deal being written about that right now. That is the hot point in my field for trying to understand our way forward on this.
But Mr. President alluded to the communication and politics aspect of the discussion. And if we have expanded on that, maybe we will be able to at least have a vision of what is probably going to happen, because without political intervention, none of all this will matter. Because the politicians, they promise to build bridges where there's no river all the time. And if they are not involved, we're not going to make any difference. So I really commend your, selecting that aspect of the topic, but I wish we could have expanded on it so we can get a broad-based discussion on it to be more informative. Thank you.
Well,
pick up on that on the second panel.
and I was going to say one word that I would say is that what we really need to focus on is education of everyone, because if the politicians think that their constituents are not going to support them and vote them back in, they're not going to do anything. So I think that education from elementary school, people need to understand issues and be a literate public, both scientifically but also politically, socially, and economically.
And on the politics, one of the real challenges is that the kind of impacts we're talking when we look at climate are much longer than anyone's reelection cycle.
Mm-hmm.
Yes.
So
Right.
and
Exactly.
the serious part about that is, if I make a decision which will in the long term help things, but in the very short term may be negative, I don't get reelected, even though I would be doing, quote, the right thing.
Right.
And that's a real huge challenge. And I respect the fact that a politician, he still wants to be employed. That's legitimate.
And that comes down to the education of the public.
And anybody wants to talk to me during coffee break about political reform, I'm happy to talk about that too, because I think that's part of the solution. So we've got to take a little break. Be back here at 10:30, ready to go, because our next panel is going to take over at 10:30. Thank you so much, you guys. Thank you very much for your great commentary. We appreciate it.